everyone, welcome back to our channel. Today I'm joined by a very interesting guest who's going to talk about bone formation. Can you introduce yourself please for the...
Yeah, of course. I'm Yukari Shiwakwa, and today I'm really glad to be here, and we're going to talk about how our new research actually used neuron stem cells to promote bone formations in mice for the cavalry defects.
So if you could introduce us about your team and just about your research a little bit and see how much we understand in the first go.
Yeah, so actually in this research, it's actually like a very large project. It has been like a lot of collaboration with other my colleagues. So there has been collaborative work from the Division of Biomaterials and Engineering, and also from the Division of Electronics. So me and most of my colleagues are from the Tohoku University Graduate School of Dentistry, and also we got some help from the Tohoku Institute of Technologies. And in terms of our project, so we actually, in a very simple way to explain this, is we actually use a comparison group of a cluster of embryonic stem cells and a cluster of neuron stem cells, and to give treatment on the Caraville's defect in mice, and we will see which one has a better bone formation after like 4 weeks of post-implantation.
Okay, so the way I understand this is that the comparison was to study nerve cells, but the connection between bones and nerves isn't like a obvious connection I'd make. So I wonder why you guys used nerves.
Yeah, it's actually a very interesting area of research, and it's actually a very new area of research as well. So a lot of common sense wouldn't actually relate nerves with bones. I mean, how is that related?
Yeah.
But actually, if you actually study the structure of bones and nerves, you can see that bones are surrounded by all the nerve systems, and nerve signals actually control the bone growth and help the repair, and it's really essential for all the healing process in the bone fractures, for example. And that's really why we actually use nerve to study the bone formation.
That makes sense, yeah.
Yeah.
I would. So if you could take me now through your research about how you guys went about testing the healing abilities of these nerve cells.
So actually, in our research, we have divided into several steps that we follow. So the very first thing is you have to make a sponge, so which is actually like a scaffold that provides structure and support for the stem cells to grow on. And then with the scaffold prepared, then we use the induced pluripotent stem cells, which you can consider as a very original form of stem cells. And we use this to give different differentiations into different stem cells. In this case, in our research, we differentiate them into the primary neuron sphere, which is a group of neuron stem cells, and also the embryonic bodies, which is like a cluster of the embryonic stem cells, respectively. So with these two different stem cells we have differentiated, we actually then can implant them into the mice, into the caraville defects, and then we will see after 4 weeks and see how the bones newly is formed, and we will see how the post-implantation is after 4 weeks. So that's what it's really about.
Okay, so I'm very curious. Did this help the mice? Are the mice better because of the cells?
Yeah, absolutely. So we actually, after the post-implantation, we have done an X-ray CT on the mice. We have actually experimented. So as we can see, this is our result from our paper, is that you can see the one with the embryonic body seeded gel implanted mice has basically no improvement of the bone formation, and it's really just looks like before. Nothing really happened there. But in comparison, if you take a look of the primary neuron sphere seeded gel, we actually have a very significant bone formation there. And you can see the caraville defect is almost covered, it's almost filled. Then we take them into the analytical, we make an analytical chart with it, and if you could take a look of the volume that the new bones generated with the first primary neuron sphere seeded gel, we can have 3.5 millimeter cube of new bone formed in this case, and whereas the embryonic body seeded gel has literally no improvement and no bone formation basically compared to the defect only group. So in this case, yes, it does help, and makes them, it fixes the defect and makes it nice better.
That's so amazing. So with such incredible results, what do you think this means for us and the future of our bone?
So actually, our research, as I said, nerve research on bone formation is very pure engineer stages, but it actually has a very huge potential in the future in terms of giving treatment and surgeries. So for example, we can potentially use it for treating major bone condition and defect for the newborn kids, and also we can potentially provide improved speed of fracture healings, and also we can help to reduce the dependency of using bone grafting, and provide a less destructive method of surgery to help patients in the future.
That's so amazing. It's so incredible to be at such an early stage of research in this field.
Yeah.
So I'm very excited to see what you guys do next.